going today deep into the conversation between all of us around, like I said already, wood fiber insulation. But I'm really excited actually having tonight here James Cornell from Live Panels, also Simona Schenker, who is our host for tonight, with her background in passive house design and architecture. Daniel, who is part of the Evitat team, who is going to manage and being basically the host for the video and all the questions we want to ask along the way. And yeah, and we were going to start. Before we jump in, I want to do an acknowledgement of country. So in the spirit of reconciliation, Evitat acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. And we pay our respect to the elders past, present, and emerging, and extend that respect to all Aboriginal and Torres Strait Islander people today. And we are here today really to listen, learn, and build a future together. So I welcome James, and in a few minutes, I will give you the chance really to tell your story, how you have actually, I would say, created that love for wood fiber insulation and your journey bringing that as a solution to the Australian market. We got also Simona Schenker, who is a familiar face now really amongst Evitat webinars and many other events, from Green Eco Design, passive house expert with a long years actually in expertise and passive house design practice, and myself tonight. So I handed over to James to make a start, to tell a little bit about your story behind Live Panels, but also your personal reasons why you have actually started that journey.
Yeah, thank you. Hello, everyone. It's good to be here. So my background, I've always been into carpentry and building, and asked a lot of questions as I was a young apprentice about the way that we did things. Why would we do that versus that? What are the benefits of this way or that way? And through those questions, discovered many ways of building, such as CLT, mass timber, prefab, hemp, all kinds of materials. But I found the wood fibre, in the context of being an on-site carpenter and applicator, I found the wood fibre system very tailored and designed as a system for tradespeople on site. A lot of the details were ironed out, and obviously a system that's been engineered for almost, now it's getting close to 100 years, I believe. It made sense on site to use it across all kinds of situations, so retrofit, internal application, external application, new builds. So I just committed to it, and the building company I had in the UK, I got everybody in my team to use it, and we just started using it. Every project, it just became the norm, and it gained a lot of interest, because even though you've got the history of use it in Europe, in the UK at the time, and particularly the little town where we were, there wasn't anybody doing it on any scale. And so then it was kind of this drive for asking questions and drive to think, there's better solutions here. We can improve things. We don't just have to keep doing the same old. That led to setting up Live Panels when we emigrated to Australia. That's getting on for 9 years ago now. We emigrated here, my wife and 3 kids, and I just committed to bringing wood fibre in. And it's a long, hard journey, as I'm sure most people are aware of. you know, doing new things and trying to raise challenging questions and encourage the industry to think differently and ask those kind of questions about the methodologies and the wider conversation then around moisture and mold and heat and things like that. So yeah.
On that note, maybe also to James is pretty much the first business community member to Evitat, and I dive deep with James in conversation around his love for untreated natural materials. But we also had these conversation around regenerative materials, which means they are actually coming with some carbon storing qualities, and like looking at what we are facing and how we need to reshape the way how we build and retrofit or renovate our homes. It's a really big opportunity to make an absolute incredible impact and create actually low carbon homes, which come with multiple benefits in health and thermal comfort and so on. So on that side, I will hand it over to you, Simona. Feel free also to tell quickly maybe a little bit about your background, and then you can make a start with the questions.
Yeah, thanks so much. Yeah, excited to being here again today and to have another chat with you, James. So we met a few times now on this platform, but yeah, it's always exciting. It's such a great product, and yeah, it's a shame that not many people know about it yet. So we definitely have to spread the word and, you know, get it known. Yeah, a bit about myself, like Sonja said, you know, I'm really passionate about passive house design. So sometimes I might go into a bit of a rabbit hole, getting a bit too much into it. But yeah, I'm really passionate because I think everyone should have the right to live in a healthy, sustainable home that doesn't cost the earth. And, you know, energy efficiency and sustainable design should be affordable for everyone. So I think that's really important. But maybe, yeah, let's dive a bit more into the headline of this webinar, which is, you know, your path to a mold-free, energy smart and comfortable home. So James, can you tell us a bit how you think about this and how you think insulation can play into the holistic building strategy?
Yeah, the current topics people are interested in at the moment is mold, damp in buildings, condensation in buildings. And this has been raised multiple times in places like New Zealand and sick home syndrome, and the National Construction Code of Australia starting to develop and change the code to what is now become known as, I suppose, vapor permeable structures. And so wood fibre is brilliant because there are a lot of other products that do good things, but quite often they address one aspect well, and then they kind of are not so great on 2 or 3 other performance criteria. Whereas wood fibre has been able to develop a system that actually works well across multiple aspects that are crucial for a healthy building structure. So the phrase that we often use in the industry is fabric first approach. And Dr. Wolfgang Feist, who created the passive house movement, was always always fabric first approach. And so that is the very structure of the building. What are the walls and what are the roof? What are they made of? Where are the air gaps? Where are the air tightness materials? And so that's really why wood fibre sparks my interest, because practically sometimes those details can be very tricky to get right, and some of them are overlooked, some of them are prioritized over others. And so wood fibre as an actual practical application on site very often delivers a great solution because of its nature, that it's timber, so it's naturally insulates itself and insulates the frame and the structure. It's highly vapor permeable. Moisture can get out very easily from the structure, so there's no issue with condensation and mold. And then obviously it's comfortable because it buffers the heat and absorbs the heat in the day, and because it's well insulated, it then maintains that nice ambient temperature inside at night time.
Yeah. And isn't it that heat can travel much slower through it than to standard insulation? Can you talk a little bit more about that? You know, if you compare just whatever earth wool or other beds to wood fiber, you know, what's actually the difference between the performance?
Yeah, so on our website, what I've always tried to do is take what's fairly complex scientific information and data and break that down into simple, easy to read graphics, I suppose. So I've got a document on our website called Performance Evaluation, and that takes 4 main criteria that everybody should ask about an insulation material that they use, no matter what it is. And the heat transfer you mentioned, Simona, there is something related to the density and related to specific heat storage capacity of the material. And wood fiber is in some cases 10 times denser than the synthetic and the fiberglasses. And then in the specific heat, it's always at least double the performance. So in reality, what that means is a synthetic earth wool or fiberglass will absorb the heat of the sun coming through the roof structure or the wall structure for maybe 1, maybe 2 hours, whereas the wood fiber equivalent will give you 4 hours as a base point. So already it's light years ahead.
Yeah, and I really like the capacity that it can actually store heat, you know, that it can keep it, which no other insulation can, which is quite amazing.
Yeah.
But maybe what we haven't talked about yet is, you know, what applications can you actually use, you know, wood fiber insulation? You know, what forms does it come in?
Yeah, so we do 2 main products: a rigid board that is a tongue and groove system. So that means it interlocks. You don't need extra timbers where the sheets join. So in terms of that externally applied continuous insulation is perfect, super quick. We then do a flexible bat that goes inside, and you can see in the image there on the screen, in the ceiling there and in the stud frame, that's the flexible bat, and the rigid panels there on the right hand side. Or the left, I'm not sure which way people can see the screen. So yeah, we do those 2 products, and the application, whilst primarily it would be an external application, the beauty of the wood fiber is it can be applied internally, and it can be applied to masonry substrates, timber substrates, and even steel. And that's a really great thing to think about for homeowners, that those people who want to do healthier buildings, want a more passive style of house, but maybe have already committed to a steel frame, or their budget only allows for steel frame, there are options available to help those people deliver a safe condensation and risk-free structure.
Yeah, no, that's great.
That's a can I jump in, James? I just want to ask, because like if we are looking across the nation, for example, like in tropical areas, for example, the consideration to avoid termites, you know, like moving into your home. And I know that with wood fiber insulation, these questions are always popping up. Oh, what about termites? You know, can you maybe tell us a little bit on that side? What that means actually with a solution like wood fiber insulation, and why it's actually a great way and a great combination, because a lot of steel consideration is going into buildings, in particular in tropical areas, and I find this a really interesting aspect to consider.
Yeah, so implementing some of the thought process that I always use, asking questions. The questions that people should ask is, what do termites like? Why do they enter buildings? What are they attracted to? Those kind of things. And usually there's a kind of blanket answer to that, which is they like moisture, they like damp and dark places, they like quick, good access, and they like a food source such as starch. And obviously, a timber frame that's had maybe an impregnation of the treatment is only as good as the skin of that timber, if you like. So by drilling holes into timber frame to run cables or pipes, that then splits that skin, which then leaves an exposed internal aspect to the frame. Then the current methods used are often don't promote vapor permeable structures. They don't allow moisture to get out. So you get perfect conditions. The advantage of wood fibre is it's a high heat treatment process. And because it's processed timber, it's essentially made up of the fibres of a timber log or tree. So therefore, the process that makes the wood fibre, it kills up and removes any starch or food source that's in the material. Then the moisture content is low because it's highly vapor permeable, and it's high heat treatment in its production. So you essentially remove the key aspects that attract termites in the first place. And then you would always apply your standard industry termite barrier details, such as the visual inspection, home guard. And I like to recommend the home guard, the blue one, because it's classed as a, what's the word, a non-leaching. So it's actually quite good for the environment as well, that it doesn't release toxins and chemicals ground or whatnot. So yeah.
That's great. Really, really great product. But can you maybe tell us, what would you say are the top 3 considerations for homeowners when it comes to, properly insulating their home and sealing their homes, when we take into account comfort, health, affordability, and also, climate resilience?
Great question. Let me ask some questions back. Do you want moisture to be trapped in your home? Do you want to get overheated and uncomfortable, or at the same time incredibly cold? So essentially, do you want to experience highs, lows in the internal temperature? And then the third one is, do you want mold and the risk of mold to be prevalent in your structure? And obviously, I won't just assume necessarily, so please feel free to offer some counter to this, but I would generally say that most people would agree to say my answer to all of those questions is no. I don't want moisture. No, I don't want to be overheated or uncomfortable. And no, I certainly don't want mold and toxins to be in my air quality. So they're the 3 things really that wood fibre is able to deliver on. And so, yeah, it's an important consideration. And in terms of cost, this is always a really big topic. Recently, we've been able to drive down the cost of wood fibre. So at the moment, the wood fibre is at its lowest price it's ever been in Australia. But there is more to do. And obviously, I'm constantly trying to work with the suppliers to ensure that we can deliver that. I've also looked deeply into and made probably about 18 months of a business development plan to manufacture wood fibre here in Australia. And that's something that's kind of, okay, it's got my name or Life Panels associated with that. But actually, for me, it's not about Life Panels or me. It's actually about the industry and a product that actually works. And people always say to me, oh, you're biased because you sell it. Now, I can totally see why people would think there's a conflict of interest there. But I'm not biased to wood fibre because I sell it. I'm biased to wood fibre because I'm analytical and I critical think and I lateral read around what is the science and why does it work. And time again, wood fibre delivers. So that's why I believe in it.
Yeah, that's the thing. Once you know certain things, you can't unknow them. And it's kind of the best products on the market. And yeah, like you said, it's still, maybe not the cheapest product. We're not talking about that, but it's definitely the healthiest on the market, which is quite exciting.
And I think in terms of dollar value to performance value, there is an argument to suggest that the dollar value is higher, but actually the performance is 3, 5, even 10 times better than the synthetics. And that's where it gets difficult, isn't it? Because how do we quantify that, and how do we educate and bring people on the journey to understand that investment? And I think I said this at the event a few months ago, the Evitat event there, where we said, think of wood fibre like you think about solar. You pay these fees up front in the knowledge that you can then start to see the benefit of the solar because there's a cool app, there's a little graphic that shows how much energy you've made and how much goes back to with wood fibre. You don't get that, because essentially it's an incredibly boring product that you never see. So, there's been a few conversations around that. How do we make wood fibre cool? And yeah.
No, that's good.
There's one question also from the audience side. Does the use of wood fibre insulation reduce the chance of mold growth compared to glass wool? And if so, under what circumstances?
That's a great question, and I believe we'll answer that later on, Sonia, with the photos of my place.
Yeah, that's fine.
Is that okay to come back to that question later on?
Yep. But there's another question maybe which goes on to what you talked a little bit about before. What type of wood are these panels made from? And and assuming it's not made from virgin forests, can you maybe just explain a bit more where it's coming from?
Yeah, so in Europe, there are certified managed forests. Now, I know that in some contexts there is concern over how legitimate those protocols are, but obviously, on the whole, most of the data and the certification can be trusted and relied upon. And so the wood fibre that's used, that we sell, the Pabatex brand, which is Swiss, and the Styco brand, which is French and German and Polish, that is legitimate and well documented and accountable sources. So the managed forests, when the trees reach mature age, they're milled into house framing or various lumber for various products. All the waste and the offcuts get repurposed into wood fibre, and also there's a recycled content, but essentially it is fully recycled material, and it's renewable because obviously new tree growth is allowed to reach mature age, and it is totally sustainable because it's carbon negative in production. So it's quite a unique and an incredible whole system and protocol around the product. It's not just the product itself that you see in the pictures when it's finished. The whole package has been well thought through.
That's great. And I just had another thought about being whatever affordability or return on investment. It's a similar thing with pacifiers. People always say, what is my return on investment? But I've never hear anyone say, what is my return on investment on the Caesar stone benchtop, or on the spa or something. People don't think about that. And I think when it comes to building a healthier home, what money are we putting on health? What money are we putting on the reduction of mold and people not suffering from asthma or other allergies? So I suffered quite a lot from asthma and we just talked about earlier, when we caught up here, that at the moment I'm a little bit sick and I have a bit of a cough, and then allergy triggered, it comes back. And I actually can't go to our office because we have obviously no insulation. There might be mold in some spots, and there is the typical ducted heating. So it just triggers my cough, and I have problems stop, coughing. And at home here, now I'm really lucky. I live in a pacifier, so it's much, much better. And typically, my asthma is gone. So therefore, just in preparation for this webinar today, I said, okay, I have to work from home. I don't want to cough too much tonight. But the question really is, how much money are we actually putting onto our health? Where does it sit?
That's a great question, and I think to pick you up on your stone benchtop comment, the thing with the stone benchtop is you can see it 24/7. People come in and go, oh wow, I love your benchtop, and there's a story around it. Oh yeah, the guys had to get this crane and they had to move it, and it took 5 people to lift it, and there's always a bit of a narrative around those kind of products. Whereas with the wood fibre, no one's going, oh yeah, it was amazing. It was like, it did this and they had to use this, and there were 6 people just fixing 1,000 square meters in 24 hours. There's none of that. It's like, once it's on, it's gone and you never see it. So I think the only option we have is some of the case studies we've done, which have demonstrated the investment into a home. And we've got a case study on our website, and then a comparison to if that home was built with kind of standard Australian systems and materials, and then the saving that those properties make. And it's not necessarily a huge amount. So there's, again, a conversation around that on the context of the build and what can be done, because that that dollar value saving is a movable scale dependent on, you know, loads of other aspects of passive house and high performance building.
James, can I just ask on the health aspect of wood fiber insulation? It's untreated, right?
Yeah.
Yeah. So that also means like it's one material less off-gassing into the air room quality of, or into the quality of air, particularly in closed off environments. And I think that's something really to consider. A lot of building materials we use as standard materials are full with chemicals, and in particular looking at the thermal envelope. If the thermal envelope isn't great, these materials are off-gassing fair bit. And this is like, we have not much actually in terms of research what that means in terms of health, but we know that these chemicals are highly toxic. And this is exactly where the residential side can make actually certain, or can take ownership of these material choices. And it's really an opportunity to consider, in particular in bedrooms and other areas where you spend a fair bit of time. And I think that's a great way also to look in general, you know, what is actually a healthy home. So it's not always just energy efficiency, but these various aspects of it. I find it really a great way to look at it as well in terms of investment. And again, it brings back that same conversation to what is your health worth. And I think if we let it come to certain issues, even more important to consider really what we are surrounded with.
Yep, definitely. Sorry, I was just answering a question. But yeah, another question maybe is, you know, if we think about, you know, if people do a renovation or extension, what do you think are typically, you know, big pitfalls or, you know, misconceptions where, you know, where people could go wrong with insulation or the building envelope?
Yeah, well, I think in some ways we've already addressed this, which is the fact that you can't see it, the fact that it's not a cool product that's got an app or a way to actually see on a daily basis or appreciate on a daily basis. And then our value is quite a misleading representation of thermal performance. And most people, homeowners and people outside of, even people in the industry, don't fully understand what our value is or how it's measured and how it affects materials. And so it then just becomes a little bit too simplistic, where people say, oh, well, I could do this R value and it's this price, so yours is the same R value or slightly better, but like way more expensive. So there's a disconnect there, which is very difficult to bridge. And so I guess it's events like this, it's amazing skilled people like you, Simona, and you, Sonia, and Armin, and the other people in the industry. And there's a lot of people in the industry now really pushing and driving these things. And it's just education and repetition, case studies. You know, like I said, our website, I've tried to get a lot of this information on there in nice little graphic forms to help people understand what that means and give it some context, rather than just, you know, these phrases that get talked about but not necessarily explained to people.
Sorry, Simona, you go.
Just one thing, as following up on what Sonia said, you know, with toxic materials, I think one thing what people don't realize is, you know, how toxic some materials are, and they think, you know, just because I can buy them in the hardware store, they must be good for you, or they're not harmful. But I find it quite shocking that many materials and paints and things that are available in Australia have been forbidden in Europe for over 30 years. So Australia is quite far behind with it. So just because you can buy it doesn't mean it's actually good for you. It could be quite harmful.
Yeah, absolutely. Yeah. And also the greenwashing aspect as well, isn't it? Where phrases that are, and we're aware of this with things like milk and organic in food, where the industry standards set just a percentage that has to meet those requirements. And so quite often you can get foods that say that they're regenerative or organic, but maybe they're only 20% organic. Same with recycled content in other materials and clothing that says, oh yeah, it's recycled and it's organic and it's, you know, sustainably farmed, but it might actually only be 5 to 10% sustainably farmed. And so that's another conversation there around what are these products, and I have to sort of pull it out and say, you know, earth wool is a classic example of that. The fact that it says earth and wool are two names that people automatically think, well, wool's a natural product, it's great. People automatically think earth, oh, well, it's solid, it's grounded, it's balanced, it's connected. And actually it's not true really in the context of that material.
Yeah, smart branding, good name.
Yeah.
Definitely. One aspect I just wanted to add to the conversation around R rating, there are a couple of natural building materials who are fairly dense, like there's also wall systems and so on, and they come with really excellent thermal performance. But exactly what James was mentioning, the R rating is actually measuring the air pockets between that. So a fluffy product will basically get higher R rating, but that doesn't naturally mean it is actually comparable. And this is where the whole conversation starts to become fairly complex. So I think they're actually very different products. Like, for example, a standard insulation bed is a very different product to, for example, a rigid like insulation panel and made of wood fiber. And I think this is really something to consider. And not to be misled even by just the simplification of R ratings. I had this conversation also, like I said, with other companies who have invested decades even in establishing really great solution to the market, but they struggle exactly with that whole conversation. Often enough, it's built on sometimes even century of knowledge, and that's something really to I think to consider as well. Often, for example, in Europe, you have building methods which stretch far into the history, and we can definitely use some knowledge and findings and inspiration even, you know, how to build actually climate resilient, because these homes have been exposed to really harsh winter temperatures and are still existing. So I think it's something really which I find really fascinating. And I just wanted to encourage to ask really the right question, and maybe even to experience in some cases what the product actually means. So yeah, on that note, I hand it over to Simone again.
Okay, so let me just check my smart notes here. Maybe, that was a question actually that Sonia asked me to put forward to you, James, and to myself, since we're both passive house designers. Maybe if you could start and could speak a little bit about how you can incorporate passive house principles into renovation and how insulation plays part in the bigger picture. You know, what are the principles you should think of?
Good question. Okay, so I think thinking about moisture, you don't want moisture to be in the building. So vapor permeable, vapor open materials. Hopefully most people here have heard brand names like Proclimer or Rotherglass or Sega. Those kind of products are membrane-based products. They're highly vapor permeable. And other principles, windows are a classic. You know, budgets often get restricted because the higher performance windows can be a lot more expensive. But essentially sealing the building and making it more airtight, the questions that homeowners should ask really is, what does that even mean? And actually it can be a negative thing to make the building more airtight unless designed ventilation is put in. And we've seen this in the UK for a long time. Homes that are leaky, whilst they're very uncomfortable to live in, actually have less issues with damp and mold because the air just leaks out. Obviously now buildings become more insulated and more sealed. The negative impact of doing that, unless you speak to somebody who's got the training, is it can cause more of an issue. So the passive house principles around airtightness, vapor permeability, insulation, thermal bridging, the windows and the doors and the design ventilation is a system that has to be thought about. And it is fairly straightforward. I think people seem a bit afraid of it, or a bit like it's an exclusive thing, or a bit like it's too prescribed. So one classic thing I hear a lot is, but I want to open my windows and my doors and I don't want to live in a sealed box. And the answer to that, when you understand the system, is that's absolutely fine. You can do that as long as you've got designed ventilation, which quite often is mechanical ventilation. Just that balance. And it's like anything, it's common sense, it's a balance. It's nothing that's 100% this or 100% that. And those principles around, just going back to those first 3 points that we raised, you know, the air gaps in the right place, the membranes in the right place, the air tightness in the right place, the junctions and all of that kind of thing is fairly easy to achieve. So people shouldn't be afraid to push those boundaries.
Yeah. And one thing what my building physics professor had taught us back then when I studied architecture was something like a 3-person household produces as much as 8 liters of water a day. And that's just by breathing, showering, cooking and whatnot. And that water has to go somewhere. And the sneaky thing with water and mold is that you typically don't see it. It can be years and years and years of buildup inside the walls. And by the time the mold comes through the walls, it typically has been there already for years, you know. So if people are sick and they don't know why, or you constantly have colds, that's a really, really big issue. And our professor back then said already, and that, you know, that was before passive house, so he didn't know that much about passive house. But he said back then that twice a day you have to do a full cross ventilation. And by that he meant opening opposite windows and doors. So we're not talking about an awning window or something, you know, a little bit or so really full on cross ventilation. But seriously, whoever does that, you know, if it's whatever less than 15 degrees outside and if it's more than 30, no one ever does that. But the humidity is still there. And as you said, if you have an old and drafty house, it's not as bad because the humidity somehow gets out. You know, you might get some humidity trapped inside the walls, but you might never see it, or might come out after 7, 10, 15 years. But the more airtight we get the homes, the more the humidity is trapped inside. And so what we actually recommend is to all of our clients that do a renovation extension, get some sort of mechanical ventilation inside to help a little bit with the humidity. And you get really great decentralized systems where they're almost just like tiny boxes that can be plugged into an external wall. And yeah, I don't want to go into too much detail. You kind of need 2 systems per room or per volume, but they're really easy to retrofit. And then obviously, like you said, there are always then the people that think, you know, I can open my windows often enough and I don't need it. I would recommend at least then to get a really good sensor, because nowadays you can get sensors that tell you, you know, obviously what the temperature is, but also what your CO2 content is and what the humidity inside is of the house. And if you see the humidity gets too high, at least you can, you know, operate and open the windows more. And potentially you might realize, okay, I need some sort of additional help with the ventilation. But without the sensor, you don't know. And that's the bit that can be, you know, quite harmful.
Yeah, and that's a brilliant reminder, isn't it? That data and collection of data that provides statistics is the best way to learn and understand the reality of a situation. Yeah.
And so I'm sidetracking here a little bit, but another interesting study was they had put sensors, you know, in bedrooms as well. And even the people who did the studies were quite surprised because they thought, you know, a typical Australian leaky home, there shouldn't be that much CO2 in a bedroom, you know, because there are gaps everywhere. But actually, in most of the bedrooms, the CO2 content towards the morning got to dangerous high levels, really, really unhealthy.
Wow.
You would wake up with headaches and be really drowsy and whatnot, even in the leafy homes. And so it just, surprised even everyone in the study. So, even if your home, there is some buildup.
Yeah. That's fascinating.
But I think maybe, I think you have a little case study you wanted to show us. Could we maybe dive a bit into that?
Yes. Excuse me.
This is your own, no, good. This is your own place, is that right?
Yeah, correct. Yeah.
Yeah. So can you maybe tell us a bit about your own journey? What did you start with? What was the starting point? What have you done, and what are your plans?
Yeah. So actually, that's a good. I don't think I sent any photos of the bricks beforehand. That was funny. So it's a brick veneer project's home, and you can see the frame there and the git rock, and then it was the blue, I think actually in the left where the pink insulation, that's the blue silver foil sarking, which is your typical building wrap, and then the pink bats, no doubt part of the dodgy scheme at the time, because the house is about 15 years old. And then the cavity between the blue silver foil membrane and the brick was, I think, 50 mil, maybe 40 mil. And then the brick just straight down to the ground. And you can see the concrete slab there in the base of the photo. And that's connected to that little strip that you see. And you can actually see the dark sort of moldy line and then a sort of cleaner line of concrete. So the cleaner line is where the bricks were sat, essentially. Very small cavity anyway. So the back of the back part of the house that I did is on the southeast and southwest, and there were two of my children's bedrooms. And since we moved into the property, the smell of damp and mold has increased and increased and increased year after year after year, and to the point where I was actually starting to feel quite concerned and afraid of what that would mean in the future for their health, because you could walk in and you smell it, you taste it, it's just not pleasant. So I actually wanted to do this for a while, but an opportunity presented itself where I was changing kind of how we operate a little bit of life panels. And so a bit of surplus material that I basically purchased and brought to my place, stripped all the bricks off. The frame was 70 mil thick. So would you mind just going back one slide, if that's okay? So yeah, you can see there, I've actually packed out the frame with some extra timber to make it 90 mil thick. And you can see the insulation, the pink bats. That was what it was like when I pulled the foil off. Gaps everywhere. So not well installed, and actually very poor in terms of performance. So you can go back to the next one now. And there you see the Woodfibre, the flexible bats, really tightly packed, and they're friction fit, so they never sag under their own weight, which fiberglass does quite often, and polyester. And then just for practicalities, you don't have to use a membrane, but for practicalities, and because I was doing the work myself, I needed time to, in between install and whatnot. So yeah, use the membrane just to make sure, and that's the ProClimber vapor permeable membrane, just to make sure the building was watertight, protect the structure and the insulation, and enable me to stage the works. Move on a little bit. Okay, so here we have, oh yeah, so I was expecting to find more mold than I found, but on the surface of the silver foil insulation that was in between the brick and that, there was mold on the surface of the membrane, and the membrane's not taped. Typically that kind of Australian standard of building, nothing's taped, so there's gaps everywhere where cables pull through, the membrane's sliced, so it really is open to a lot of moisture and damp in that context. So obviously we wanted to reduce the risk of that. A major aspect of damp and mold transfer was the thermal bridging through the concrete slab. So this blue line that you see here is what's called XPS, and that is a high dense, essentially polystyrene insulation. It's not quite polystyrene in the ball sense, it's actually a solid product, high density. And so what I did there was put that plastic starter profile with some expanding foam and some compriband, which you see in the right of the picture, the grey little rectangle inside the wood fibre there. That's called compriband, which expands. So it creates a totally weatherproof and waterproof seal because it expands into all the voids. So in the case of the slab, it's an uneven surface on the floor. And so the compriband actually fills that void. So I did that to protect this and insulate the slab, to stop the slab conducting so much cold that we were actually getting condensation and mold on the underlay underneath the carpet. And anytime, let's say if the kids left a cuddly toy or a jumper on the floor, within a matter of hours you would pick up that jumper or toy and smell it, and it would smell musty and damp. So that was obviously a major issue. So yeah, then the wood fibre goes on, and in this context, we're going to render the wood fibre. So that's a great thing with wood fibre. You can render it or you can clad it, and you can do that internally and externally as well. So it really is a good product to use for retrofit situations. So because we were cladding it, where you see a vertical join where it's not tongue and groove, you have to use the compriband expanding tape. Around the windows, I don't know if anyone's picked up, there's a little blue strip as well. Now this is where the project kind of lets itself down, and I am embarrassed to share this but it's the reality of a situation. Don't have the funds to invest in high performance windows, and so what I did was I've designed this where retrospectively now I can take out those windows from inside and replace down the line with timber double glazed high performance windows. But in the meantime,
very smart. Don't downplay yourself.
Okay, yeah. Thank you. Yeah, and that is part of the Enefit, the Passive House Enefit staged works. But I think typically, and the way my mind works is as a project manager, I'm like, this isn't that efficient, but it's the reality of where we're at. So the reason for that little blue strip under the window is to create a 30-degree sill that the water can run off, and it's just a classic detail, which is when it's rendered, the blue at the bottom where it meets the ground, and any surface that water can land on or bounce up onto should be protected with the XPS polystyrene, because the render is lime based as well. So the system is designed to take on a little bit of moisture, but it's also designed to release moisture really quickly and safely. So that's the only reason for the blue there. Typically you wouldn't do that because you'd have proper sills and reveals. So yeah, that picture on the left is some primer. So because the top of the wall was essentially an exposed edge of wood fibre, and that's where it went into the roof space, because we haven't done the roof as yet, we still needed to protect the top of the wood fibre from condensation and moisture dripping down off the roof. So I just put the primer there, which then I used a tape, the Proclimer tape and the Proclimer membrane, and wrapped that over the top and stuck it to the top plate of the house so that the wood fibre is protected from moisture there. The render, let's move on to that. So it's a 2-coat system, and you apply the base coat, and you can just about make out some sort of notch trowel marks there. It's about 5 mil thick. You create some notches with the trowel, then you push a fiberglass mesh into that base coat and essentially push that in with the trowel. And then you go over the top with a second coat, which is another 2 to 3 millimeters thick. And I think there's some other good pictures of the render if you scroll forwards. Yeah, so you can see the mesh there on the right hand side. So you can fold the mesh around corners, and you can either do, leave a natural hand finished corner, or you can apply render beads to the corner. And then what you see on the left there with the renderer's hand in there is a second strip of mesh. So where you have cables or on the corners of windows and doors, I think there might be another image of a corner strip actually. Scroll forward.
This one?
No, next one.
There's
Oh, that's it.
yeah, because I
Okay, no, go back.
all of them.
That's all good. Just go back one slide if that's okay.
Yeah.
Thank you. Yeah, so where the window is there in the top left, so you have the mesh that covers everywhere, and then you add a secondary little strip of mesh like you see in the photo, but on the diagonal across the corner of that window. So you do that on all corners, and that's just a secondary protection for expansion and stress cracks. So did that. And then move on to the next photo, the final one. So I actually wanted to just try out the beads, and that's a really micro bead, they call it. So it's barely got, I think it's like 1 millimeter of plastic on the corner, so that it looks like a super clean, sharp edge. And I'm sure people will be frustrated. Oh, show us a great picture of that. And typically it's the kind of thing that you forget to send a picture of. So I'm sorry about that. But yeah, then the second coat goes over that, renders into the bead. And in this case, what I wanted was a float finish, they call it. So you can kind of just see some striations of the actual render itself. The beads in the render, the grit, if you like, is around about 1 to 2 millimeters. You can sponge finish it, which brings the grain to the surface, or you can trowel it where it's a little bit more smooth, or you can do this float finish, which gives a little bit of the striations of the trowel and the beads, the coarseness of the grain moving around. So you get a real flow feel to it, and it looks really cool. So I just wanted that. You can color it as well, but chose not to do that. Leave it in its natural pigment, as it's a lime-based product. So yeah, and then that was pretty much it.
That's great. So you finished the entire outside?
No, so I just did the 2 back bedrooms, which were the only 2 rooms in the house that have had massive issues with damp and mold. And so this was done, when did we finish that now? Almost a year ago, probably.
Nice.
And so now we've come into the cold season, the wet season, a lot of rain, and obviously very cold. We're not quite as cold as Melbourne. But yeah, so we now for the last 8 months I've been monitoring. I've got these little relative humidity thermometers in each room, so just promoting your comments, Simona, about tracking data, analyzing data, having little ways to check it. And the surface temperature in those bedrooms previously to the works would get down to 9 degrees, 11 degrees on the surface of the wall. So obviously that tells you that you're going to get into that prime zone of mold growth on the surface, which is what's happening. And then now there's no smell of damp or mold. The whole wall is totally dried out because the concrete slab is protected. We don't get that thermal bridging through the slab. So now, clothes can be kids, what kids can be like, clothes left on the floor, toys, and there's no smell of damp or mold. And yeah, we've managed to turn that around. It is still quite cold at times in those bedrooms, but that's down to the fact that the windows are terrible, aluminium, rubbish, and there's no insulation in the roof, in the ceiling space. Yeah. So yeah.
It's a journey of improvement.
Yeah.
Which I really appreciate that you're sharing this, because often enough, like we can't also do in one go the big thing, but it really showcases you can actually improve the quality even of certain areas by doing it even in parts. And there's also another question which is directly actually related to the lime render. If water can pass through the lime render, do the walls need to be protected from rain in order to prevent moisture from absorbing into the wall from the outside towards the inside?
Okay, yeah, great question. And what I didn't show in the photos is once that second layer of render is finished, there are a few various options that you can do to then seal and finish that wall off. One is you can do a cork spray finish, which is a naturally repellent and actual certified moisture barrier. but because it's cork based and it's very permeable, it fits into that criteria. But what I did was I wanted to leave it natural, so I applied a deep penetration eco sealer, which is a water-based product, but it's translucent in its finish and it's deeply impregnating, but it actually beads, the water just beads on the surface and gets out. But to answer that even deeper on a technical level, what I actually did was carry out a woofy analysis on the exact structure to make sure that what I was doing for the context of our block, our house, and all the weather conditions, that it was going to work. And what it did suggest in the woofy was that if there's a crack in the render, then there could be a risk of mold growth on the surface of the wood fibre due to excessive moisture. But obviously, we take those precautions to make sure that, firstly, it's installed correctly, firstly, that the spacings and the fixings are correct, secondly, that the mesh and then the double strips of mesh, all of that is done properly. And so, yeah, and because it's my place, I'm obviously more paranoid than you would be necessarily on a client's house. And that's partly why I wanted to do this, you know, to show a bit of a showcase of, you know, you don't just say stuff in a webinar and expect people to just nod along and agree. It's actual, you know, put this into practice. And I really pushed it, you know. I could have done it a lot easier. Like, for one example, I would probably prefer to use cladding and ventilated facades, because that is super safe, well tested. You know that no matter what happens, it's safe. Whereas this is a little bit risky. That, you know, I don't know if, say, the gardener comes round, or, you know, someone comes around with a ladder and, you know, they bash into it and then it's damaged it, and I don't know, and 6 months goes by, and all of those kind of risk factors. But on the whole, it's a safe system, it's well tested, and we can use scientific data like woofy to analyze what the risks are and what to be aware of to prevent future damage.
That's great. So what else have you planned for your house? You know, do you have any future plans for further renovations or?
Yeah, naturally. I would certainly like, next steps would be to replace the windows and the doors. Next step after that would be replace the whole roof and do our standard wood fibre roof system. And then the step after that would probably be to then finish off the rest of the walls with the wood fibre system. And in true project manager style, I would probably have to consider, is it better to knock it down and start again?
Oh my God, yeah. But
I think from the carbon perspective, I think you are doing actually the right thing, you know, trying actually to improve it as much as possible. I know at the moment, you know, sometimes with existing buildings, there's a lot of discussions around, you know, is it worth versus actually choosing the better new material choices. But yeah, I think we have 8 million homes. If we are wanting to be more serious about embodied carbon and what that means actually on that scale, every single home, which can be like, in general, like if it's possible to keep it as it is and improve through retrofitting, home improvements and renovations better than anything else, you know. And we had previously great examples. Even Simona, you have taken us through your renovation journey, improving the unit to a really comfortable 8+ star home. Is that, do I remember that right? From, what was it original?
I think 0.7 stars, and we went to 8.4.
Yeah, so quite amazing journey as well. And yeah, you can actually do it. Yes, there's certain consideration. You need to know what you're doing. But this is, I think, where we want also to facilitate actually between professionals who have the experience and good material choices, and really to make that possible. Because in the end, all of this costs money, but building new costs as well a lot of money. And on that note, I want to jump in because I used actually the example James renovation choices and also certain consideration actually with future renovations, and created an example for the logbook, how you can store and track and measure these improvements. And this was, for example, an outcome of his logbook, and in particular highlighting here, for example, when you are adding certain improvements, what that means. And what we want to achieve with logbooks is really to make that visible. So we are going back to that discussion, you know, that, for example, some investments are significant in thermal envelopes, but they are not as visible as a benchtop, for example. And we want to make that visible, and with that gives us and every renovator the opportunity to tap also in green loan finance, for example, in future, but also giving you better opportunities, for example, in particular around risk mitigation, to have better options with insurances, because there will be certain impacts of climate risk applied to properties and homes. For example, there's a discussion going on in terms of climate, mandatory disclosure of climate risk around properties, and that will be applied to every single home in future. And this is a great way actually to show that you have done certain areas, and it will be incentivized as well with the right finance opportunities, with other opportunities. And of course, we need to decarbonize. So the logbook is a good opportunity to start that. And we are an impact venture. We invite people, we are making it possible actually to use it for free. And we really want to enable that ecosystem between actually the right professionals, the right material choices, and better outcomes for renovators. So on this note, I really want to say a big thank you to James tonight, and also Simona. I have a quick look if there's anything else we might have missed, maybe.
Yeah, one thing, I know we're running out, but I think if you could, James, maybe tell us a little bit about your new collaboration, or the new thing you've started. Maybe just a brief intro.
Yeah, definitely. Thank you for that. So yeah, basically in the last 18 months, we received a lot of inquiries around detailing, structure, all that kind of stuff, consultancy based work. And so whilst Life Panels is geared for that, what we've found is there's a better opportunity to deliver more aspects of consultation that are kind of aside from wood fibre. And so yeah, me and a brilliant gentleman called Spiro Hasiotis, who's been in commercial and project management and business development, we've got together and set up a new company called 81, and it's 81 Consult, Manage and Build, and to offer that wider range of services, passive house design, woofy, thermal bridge analysis, all of those kind of things, as well as helping homeowners, builders and architects with detailing of how you actually build these structures to make sure that they're risk-free. So yeah, pretty excited about that. It's good.
Right. I'm sure we're going to hear much more about it soon.
Absolutely. Yeah. That's great. That's exactly what we need. We need more expertise in that area, more who take on regenerative material choices, and then, yeah, the outcome will be better homes for everyone, and with less environmental impact. So yeah, on that note, just to mention also, Life Panels is on Evitat, available for inquiries as well. So feel free to hit that button and to send inquiries to James directly. And if there's anything else, the webinar will be shared as a recording in community in the next few days. And if there are any questions, just feel free to post that in community. And I'm pretty sure James or one of us is more than happy to answer anything. Well, again, thank you, Simona, Daniel, and in particular, James, for your time.